Okay, so let's have a look at the Junior Certificate Higher Level Maths Paper 2 for 2019, question 6. So we have a diagram here, and it's made up of two equilateral triangles. You have this triangle here and this one here, and two parallelograms, this one and this one here. Three angles are marked, M, K and N. Write the correct letter in each space in the table below to show what type of angle each one is. Use each letter only once. So we have an acute angle. Well, K is the acute angle because it's less than 90 degrees. The reflex angle is greater than 180 degrees, so that's N. And then an obtuse angle then is M, that's the one greater than 90, less than 180 degrees. Okay, so work out the size of each of the angles K, M and N. Remember that the two triangles are equilateral, so they're telling you again that these things are equilateral. So if this triangle is equilateral, it means all the sides are equal and all the angles are equal. So the sides are equal would mean that that side is equal to that side is equal to that side. Here in this case we would be looking at that side being equal to that side being equal to that side. Now these sides are obviously different from these sides here. Also actually, because we have a parallelogram here, that side is going to be equal to that side, and this side here is going to be equal to this side here. Those two sides are going to be equal, and these two sides here are going to be equal as well. It may be useful later on, I'm not sure yet, but we'll read the question and see. Also these are equilateral, so we can put in the angles as well. So if they're equilateral, it means it's 60 degrees, 60 degrees and 60 degrees here. So the three angles are 60 degrees. And the same over here, K is going to be 60 degrees, this is 60 here, and this is 60 degrees here. You could also work out these other, you could also work out M. We're probably going to have to do that. Yeah, work out the size of each of the angles K, M and N. So let's do that. Well, K is actually the easiest one to do first. So K here is just going to be equal to 60 degrees because it's vertically opposite. Vertically opposite this angle here. So M then is just going to be equal to, because we have a straight line going down along here, that's going to be 180 degrees, so M is just 180 minus 60. So M is equal to 180 degrees minus 60 degrees, so that's just 140 degrees. No, it's not. It's 120 degrees, I think, isn't it? 120 degrees. Yep, 120 degrees. N then, how do we work out N? Well, there are a couple of ways of doing this. What you can do here is, let's see, we're going to look at this parallelogram here. If this is 60 degrees, this angle here must be 120 degrees. So this must be 120 degrees here. I might do that in just a darker color. So this is 120 degrees here. So if that's 120, this must be 120 here. Opposite sides of a parallelogram. Opposite sides and opposite angles of a parallelogram are equal. So if these two are 120, these two here must be equal as well. So if we add these two angles up together, we get, let's see, 120. 120 times 2 is 240 degrees. The other two angles are equal, so if we take all four angles of a parallelogram, will add up to 360. So 360 degrees minus 240. That'll give me, let's see, 0, 2 and 1, 120 degrees. So these two angles here add up to 120, so just take 120 degrees divided by 2 will give me 60 degrees. So this angle here is going to be 60 degrees, and this angle here is going to be 60 degrees here. So once I have that, then I know that this angle is 60 degrees, this angle is 60 degrees, so all the way around here is 360. So all I've got to do is take N, then is just going to be, the N here is just going to be 360 degrees minus 60 plus 60 degrees. So that'll give me 360 degrees minus 120. So that will give me N then as 0, 4, 240, I think 240 degrees. So n is equal to 240 degrees. I mean, that's one way of doing it. What you could do also, there are probably a number of ways of doing it, but you could extend this line out here like this. So then if this is 120 degrees here, this angle here must be 120 degrees as well, because they're corresponding. This is 60 degrees here, so this angle here is 60. So this angle here must be 180 minus 60, which is also 120. So this is 120 here. So 120 plus 120 is 240. That's another way of doing it. There are probably numerous other ways of doing it as well. Okay, so let's have a look at part C then. The two equilateral triangles are not the same size as each other. Siobhan says that the two triangles are similar, but they are not congruent. Give a reason why the two triangles are similar. They are similar because the angles are the same, but the sides are different. They're different sizes. So the three angles in one triangle are 60 degrees, the three angles in the other triangle are 60 degrees. So the angles are the same, but the sides are obviously different, different sizes. So that would be the reason that they're similar triangles. Give a reason why the two triangles are not congruent. So they are not, I've already answered that really, they are not congruent because the sides are different. So the sides are different in both triangles. So similar triangles are equiangular. So similar triangles are equiangular. Congruent triangles have the same, are equiangular, but the sides are the same size as well. So they're not congruent in this case because the sides are different in both triangles. Now the small triangle in the diagram has sides of length 4. The big triangle has sides of length 8. Use this information to construct the diagram in the space below. Clearly show any construction lines used. Now I'm not really going to be able to do this properly, but I'm going to have to do it freehand. I'll show you what to do. You're going to have to use you know, compasses and rulers, straight edges and things like that to construct this. So I'll show you what to do, and you're going to do it a lot better than I'm going to do it here. So let me just start it anyway. The shape, we're told that the sides of the big triangle are length 8. So what you're going to have to do really is just start from here and draw a straight line here that's 8 centimeters, and then another one that's 4. So from here to here, that's going to be 8 centimeters, and from here to here then that's going to be 4 centimeters. Now you're going to have to draw two equilateral triangles from here. So what you would do is get your compass and measure out 8 centimeters on your ruler. So what your equilateral triangle ends up down here. So you're going to have to put the pin of the compass here and draw an arc down here, and then do the same from this side, and you should end up with an arc here. So then just join up here to here and here to here. So this will be 8 centimeters, and this will be 8 centimeters here as well. So you do the same over here with your 4 centimeter triangle. So again, get your compass, measure out 4 centimeters, and you're going to draw an arc from here out to here. Then the same from here, measure an arc 4 centimeters from here out. So it's going to be something like this. Whoops, not great, but get the idea. And then just join it up. So you're going to do, let me do that in white actually. So you're going to draw a point here, and then from here to here, and from here to here. So that's going to be 4 centimeters, and this is going to be 4 centimeters here. So now you've got to draw 2 parallelograms. So the way you're going to do that is you're going to take your compass, again start here, put the pin of the compass here. You're going to measure 4 centimeters on your ruler, and you're going to draw another arc. So you're going to draw an arc up along here 4 centimeters long. So you're going to draw an arc 4 centimeters long. You're then going to measure 8 centimeters on your compass, on your ruler using your compass, and you're going to start up here. You put the pin here and draw 8 centimeters. So you're going to end up with an arc, I don't know, looking something like that from here. Maybe down a little bit, but so you're going to put a point here, and then you're going to connect this up, and then you're going to connect this up. Okay, it doesn't look much like a parallelogram, but you get the idea. So that should be parallel to that. That should be parallel to this one here. This also should be 4 centimeters. Doesn't quite look like the same as this side, but you get the idea. You do exactly the same down here. Get your compass and measure 8 centimeter, measure an 8 centimeter arc, so maybe something like this, and then from here measure a 4 centimeter arc, or draw a 4 centimeter arc from here. So again, this is where you're going to connect up your lines. So you're going to connect this one to this one, this one to this one. Again, doesn't look great, but so you get 8 centimeters here and 4 centimeters here. And that'll be it really. This is your diagram. This is your equilateral triangle. These should be 60 degrees, 60 degrees, and so on. I think that's all we had to do here. Let's see, what did they say here? Use this information to construct the diagram in the space below. Show clearly any construction lines used. So we have these arcs in here. There would be our construction lines. We've put in our measurements here, 8, 4, 4, and I mean these are all 8 as well here. So you could put in 8 centimeters here, 8 centimeters 4. Yeah, we have everything in that we need. Okay, so that's the end of this particular question.